So in this video we will integrate 1D river model with 2D catchment. Okay, for example, we have previously prepared the this 1D model. As you can see over here, we just need to create the catchments. So select polygon. Okay, select polygon, then delineate the catchment. You can delineate the whole area, or as per your project requirements, so you can do it. Okay, so for example, this one we are just delineating this small catchments surrounding the 1D river model. Okay, so just delineate it, right, and give name is 2D CA, 2D catchment. That's mean. Okay, over here, yeah, yeah. Just double click on this and go to the model. No, before, no. We need to cancel it. Sorry, we made a mistake. We need to define the properties of the 2D catchments. Okay, just wait. We can't cancel it. We need to define the properties. Just okay. But over here we didn't define, that's why we need to define that this will be normal condition, terrain sensitivity matching we need to select. Okay, then again we need to create the again we need to create the mesh. Okay, yeah, this one. All right, this is the we are creating. All right, this is the way. All right, let's go. Yeah, for this one we have to select the river model. Please go to the model. We need to integrate with the build bank connection. Okay, now bank connection has been built. Again we need to build bank connection. Okay, this is the red line is showing because we need early we have just created the mesh. Okay, before doing any kind of change in the mesh in the 2D zone, you have to recreate the mesh. All right, yeah, just clear the mesh. Just wait, it will disappear when we will upload the mesh, generating mesh, right? Just look at. All right, so you can see this it has been disabled. Okay, right. So our 1D model has been integrated with the 2D catchment. So for this one, if you have an inflow boundary, you can define it. Otherwise, you can use you can use your node as a inflow boundary. Okay, so there's no error. All right. So over here, you need to recreate. You need to create the uh, simulation run. Just right click on your model group and yeah, over here we need to define the first of all rainfall event. Okay, if you have a design rainfall, so you can use it. uh, you need to select the generated design rainfall. Otherwise, if you don't have, then you need to define it. Okay, 1D 2D rainfall. All right, yeah, this one. Okay, the SCRC and rainfall. we are using 6 hours duration rainfall. Okay, right. Yeah. And then there will be time step for this it is a duration interval, at which interval you are putting your rainfall. Okay, over here antecedent depth is 0. We are not considering any kind of rainfall over there. Okay, then you just need to see, open your rainfall depth and just look at, we have just a sign. Okay, just need to, yeah, this kind of rainfall depth is appearing. Okay, all right. For this catchment we will apply the rainfall, and there will be one inflow boundary for the 1D river model. Okay, so over here you need to check the properties, profile properties of the rainfall. So there's a profile properties is m6 hyphen sign. So you need to copy this profile name. It should be matched as per 2D catchments profile, rainfall profile. So over here we need to paste this one and need to recreate the mesh again. Okay, right. All right, this is our rainfall event, 1D rainfall event. You can apply for 24 hours, but we just applied for 6 hours because we can get less time to simulate the model. All right, yeah, just validate the model. All right, there's no issue. All right, then uh, we can use this one, and we can this not th or yeah, th, just save it the network. First you need to validate the model, and after that just need to mm, save it. Otherwise you will face the error. We are putting two boundaries, one is rainfall event, one is inflow boundary. Okay, all right. Yeah, over here 6 hours, just need to simulate. Okay, it will take little bit time, so you have to wait, and after that you can see it how it is going to be simulated. Okay, all right. Just wait. Okay, we will holding it for a moment, then we will see. Oh, it's an simulation has failed, so we need to find out what's the issue over there. Simulation has successfully failed, so we just need to see what's the issue. So go to the log result report. Over here just see it. As you can see, these elevations problem. If cross section has minimum less elevation in compared to the bank, and bank has less elevation in minimum elevation of the cross section, then you will face an error, because bank has bank must have higher elevation in compared to the cross section minimum elevation. Okay, if minimum elevation or cross section bottom elevation is around 100 meters and your bank elevation is coming around 92 meters, so that's going to be a problem. Okay, over here we can see, so what's the difference it is coming with the minimum elevation 0.338. So we can raise 5 meters or zero point 0.5 meters or 1 meters elevation of the bank, so that bank uh, bank will be higher in compared to the uh, ground. All right. Okay, so we have to do this, we have to incorporate this design into our model. All right, that's the thing. So we need to close this one. Okay, all right, we need to delete these bank lines. Select these bank lines and delete it. Again you need to, yeah, over here you need to select the river reach upstream section and go to the model and go to the river reach and create bank lines from section end. Okay, this is the way. So say this has been created. So over here you need to select bank level and adjust current level. So we are raising 1 meter, adding, as you can see, select adjust absolute and add. So you can see 1 meter elevation of the bank has been increased, and we are just defining the modular limit and this coefficient discharge over here. Okay, so we have to do for each bank, left and right. Okay, yes, adjust one, right, set new one. That's why this thing you have to consider every parameter should be logically work, otherwise you will face this kind of model simulation error. Okay, all right, because I'm just putting everything you can face problems in your model, so you can identify the problems and can work out. Okay, so these are the thing you have to do. Okay, not add set value, just adjust, we need to adjust cell current variation. Yeah, just one, select this. Okay, so as you can see, 1 meter elevation of bank has been increased or raised. Yeah, just adjust, set, right, one coefficient discharge and modular limit 0.95. All right, I think we didn't define further, right? Oh yeah, that's it. Set value 1, coefficient discharge, bank elevation is set new, yeah, initial 0.95. All right, now we just need to, yeah, okay, that's been assigned. Now you just need to select, the river model. Okay, sorry, yeah, we need to select river model also. Now you need to go back and then river model, then click build banks from selected lines. First we create the bank lines, then after that assigning every parameter you need to click build bank lines, right? So we have also created the bank connection and build bank lines also. All right, just click on build bank connection, and then again go to model, then go to again and build bank connection. So bank connection means your 1D river model is going to be integrated with 2D catchment. That's the mean of that. Okay, all right. So as you can see, there's no error. All right. Same thing for this river model. You need to look out if there's error or not. All right. You can just validate your model. So as you can see, there's a error mess. We need to recreate the mess. That's why error was appearing. Okay, all right. This mess is creating. Just need to wait. After mess generation, you need to load the mess and then revalidate. Then you will see if there is any kind of error or not. All right. Click on mess ready and load mess. All right. So you can see just validate model again. So there's no error. Okay. Now good. Now good. Go to save it this model, right? Yeah, over here. Then you need to re uh, we have already one. Inflow is already there, or we can create new inflow. Okay, 1D and 2D inflow. Okay, I think okay, we are just showing that how we will assign this inflow boundary. Okay, open. Over here we need to define sub event properties. We need to define that what's the time interval we are going to put. So 10-minute interval will be 10 and small m, then apply. So every interval will count as a 10 minutes. Okay, we are using a class to interpolate the hydrograph, one lump sum hydrograph. Okay, all right, just open the hair class. Okay, if you have a hydrograph in your Excel file, then you just copy and over here you can paste it. Okay, we are just using to create the hydrograph easily and then can work out, right? Over here, below hydrograph. Okay, this is the hydrograph. We have there's a option to interpolate the hydrographs. So you can just we are putting the 10 minutes interval, and for 3 hours has 1000 cubic meter flow, and for 6 hours just 20, and then interpolate. So you have values for 6 hours, interpolated value. Okay, just copy, and peak value is 1000 cubic meter per second. Copy it, and yeah, go to your over here and paste. Right click and paste. So it will ask one window open will be appears, then it will need to add time staples. So you can see this is your hydrograph. over here Over here you need to see we are assigning the inflow at the node. Okay, this is n1. So same profile properties should be there. Profile, put the name object reference number, so it will be the same name n1. Okay, apply. Okay, and close it and save it. All right, this is the way you need to do. Okay, Yeah, this is the way. All right, you need to validate model again, and there's no error. Just save it the model. All right, yeah, that's the way. Now you have to resimulate. Just update your network and select your inflow boundary as you created. This is your new inflow boundary, right over here. Okay, all right, just click simulation. Okay, run file name, you can put it whatever you want. Okay, it will take just little bit time to complete. Sometime if your have mesh size very small, then it will take around 12 hours or 13 hours, so don't be afraid. It took time, so it will take time. Don't be afraid. Okay, need to be patient, very patient. Over here you can see job progress, what simulation is going on. Right, for 6 hours we are just running it. Just need to wait. Okay, just wait. Okay, initializing first, it will be start as initializing. Initializing means that it will initialize every structures or every kinds of elements. So it has been started, it is simulating now. Okay, so we need to wait. Okay, now it has been run and there's a warning. So warning is mean that some structure is insufficient to carry the your peak discharge. All right, so over here we can review the results. So just need to take out your ground model over there, then yeah, then see the maximum. But you can't see the 1D flood depth into the your wadi or river reach. So for this one, right, you need to right right click properties and themes. Okay, then just go to the open the flood and apply. Okay, you need to apply, and you will be able to see 1D flood depth. Okay, right, yeah, and now you can see it. Yeah, you can also open the arrow length, and you will be able to see the where what is flowing in which direction. Okay, so as you can see, water is overpassing, and then look at this, water is overpassing through the bank lines, and that is flowing towards the catchment. Okay, as you can see, we have also applied the rainfall, so that's why inundating flood inundation is happening surrounding the catchment. So that's the thing. Okay, you need to review every results in your models, so you will able to find out what's the reason is water is flowing towards this depression, or why what is accumulating at this point or at this location. That's the main thing you need to find out. Okay, all right. Let's say you can review the graph of these cross sections. Yeah, you can select the flow depth, section flow, section depth, everything is there. You can review it and flow number also. You can see it. Okay, right. This is the thing. Section flow is happening so over there around 800 cubic meter. So that's mean 200 cubic meters flowing overtopping the bank. So that's going to be that is joining the uh, catchment, 2D catchment. All right, that's the thing you have to look at. Right, these are there. You can see the cross section. So water is overtopping the bank, as you can see it. Right. Okay, you can see it over here. You can also do the cross section by manually, and you can visualize these things. As you raise the bank 1 meter elevation of the bank line, so it will not consider into them in terrain. It will just simulate to minimize the to make a logical phenomena between the cross section and the bank. So that's why you have to be very careful if you are going to work on one detailed design of 1D river model. So you have to delineate the bank elevation exactly. That should not be overtop the bank. Otherwise, if you overtopping the bank, if sometime it happens that bank has a good elevation or has a higher elevation, but after the bank just behind the bank surrounding the area of bank, so there is a low elevation, there is some depression. So if you are going to delineate putting your bank passing bank on that depression, so obviously you will get less elevation. Okay, that's the thing you have to look at. Right. Yeah, just you can review the also the breeze opening flow. What's the breeze results? Just graph, click on graph and see, click on again breeze and click on opening or breeze deck. Everything you can see it over there. Then deck flow. So you can see there's no deck flow. Deck is not overtopping as you can see it. Okay, and then graph level. You can put it the level also over here. Yeah. Yes, and graph. Yes, breeze opening and see the opening flow, downstream flow depth. You can see it. Okay, so you can see 800 cubic meter. It is coming. Okay, all right. You have to look at these things. Let's see that view long sections. Long section is available. Bridges over there and what is flowing towards the sky this way. Okay, right. It is also similar as high cross as you do. Okay, it's not a big problem. You can also do that easily. Okay, right. You have to do more practice so that you can understand